Good morning, everybody. Welcome and thank you very much for joining us today for a new Europractice webinar. Today we have the second episode in the series about Pragmatic's FlexICs technologies. Last week, we have an introduction to Pragmatic Flexible Integrated Circuits by Dr. Francesca Botacchi. This episode is already in our YouTube channel, so if you missed it or if you want to watch it again, please do not hesitate to type in YouTube Europractice IC and look for this fantastic episode. Today, we have two great speakers, Suman Balaji from Pragmatic and Adil Masood, and they will go a bit deeper into the topic of Pragmatic's FlexIC technology. They will speak in detail about designing in this new technology, about the PDK, and of course, explaining us how you can prototype in this service through the Europractice multi-project wafer service. So, having said this, it's time for me to introduce our speakers. First, Suman Balaji from Pragmatic, as I said. Suman received his master's degree from University of Lund in Sweden, focusing on integrated circuit design. After that, he joined IMEC for an internship and thesis work, where he was more focused in digital IC design. In 2021, he joined Pragmatic Semiconductor as a design engineer, and he was focused on the design of digital standard cell libraries, digital ASIC circuits, and the development of digital and analog IC flows. Currently, he works in the foundry engineering team as the main technical contact and interface for academics, R&D, and industrial foundry customers. Then our second speaker of today will be Adil Masood from IMEC. Adil received his master's from Cochin University in India in the topic of photonics. After that, he joined IMEC and UGent University as a researcher and working in the topic of integrated photonic circuits. In 2016, he started to work at IMEC in activities related to operations and business development of IC prototyping services. And nowadays, he is the leader of the FlexIC MPW service at IMEC, and he's working in the organization of several training courses and developing course material for Europractice trainings. So with all that, I now would like to give the floor to Suman and Adil, and I wish you all a very nice webinar. So Suman, the floor is yours.
Just a quick introduction, Maria. I'm happy to be here on this Europractice webinar to speak more about our Pragmatic's FlexIC platform and all the technical details related to that. So quickly going through the content, what I will do is I'll introduce about Pragmatic Semiconductor, what we do and how we do it. I will deep dive into technical details about our Pragmatic FlexIC PDK, how our technology stack looks, and what EDA tools could be used to design in our technology. Then I would touch briefly upon manufacturing of wafers, how to test these wafers, and also give you some application-based examples and publications. At the end, I would like to conclude with why use our Pragmatic FlexICs and related services. After that, Adil Masood from Europractice would briefly touch about how to access Pragmatic's FlexIC PDK and how to access the MPW services. I hope by the end of this presentation, you will have very good understanding about the technical aspects of Pragmatic technology. I want to inspire you to create new ideas, circuits, and device architectures using our world-leading unique technology platform. So what we do in Pragmatic Semiconductors. We make integrated circuits, which are highly flexible. As you see, this is our manufacturing line. We don't make them using traditional silicon, but we have active devices and multiple layers of metallization to connect your circuits. I want to emphasize on the keyword, which is flexible. Our technology is flexible. It's IGZO-based thin film transistors. The best thing about our technology is the speed and agility of our manufacturing process with a quick turnaround time and rapid turnaround time. With this rapid turnaround time, you could do multiple tape outs within a year. Here you can see our end of line wafer, how it looks. And it's also possible to transfer this wafer from glass substrate to a frame and then dice these wafers for you. Then how we make this FlexICs. I briefly want to touch about manufacturing of these. In our manufacturing, we don't use any long or complex duration steps like in silicon. We use simple deposition, etching, and repeat the stack. Repeat this over a process of layers to complete our stack. So all our process does not have any long duration. We don't use very high temperature when manufacturing any of these layers. Also, our usage in water is very minimal. The tools that we use in our manufacturing line are not very expensive and does not include any complex process. Based on all these advantages, the cost of manufacturing for our ICs and wafers are very less. We could very fastly produce all the wafers and be more environment friendly. Okay. We have our offices at Cambridge, UK. And then we have our manufacturing site in the north of UK, which is Durham. You see, this is one of the snapshot of our FlexLogic 1 line. This is where all the Europractice MPW ICs will be fabricated. We also are going into a new fabrication line, again in Durham. It's the FlexLogic 2 line. If you have any revolutionary ideas in terms of manufacturing, you could also have your own fabrication line in specific customer sites. This is possible. So now we looked at Pragmatic, what we do. Now I would briefly like to touch upon how our technology stack looks and how the PDK looks. So briefly going into the technology stack, our substrate, the base substrate is made of polyimide, which is highly flexible in nature. And we have active layers, which consists of front-end offline devices and back-end offline metal layers. In front-end offline devices, we have dedicated N-type TFT transistors, which are metal oxide IGZO-based. Then we also have resistors, which you can build, and capacitors. We have 4 routable metal layers dedicated for your routing. Also have 1 metal layer that's RDL, which you would interface to the outside world. And you have appropriate vias to interconnect between these metal layer stacks. Again, the outside world interface is the aluminum RDL. It's 0.5 micrometer in thick with the passivation, top layer passivation of 1.3 micrometer. So I would briefly like to touch about process design kit. What are the main features? Our current technology offering is called LLN 2.1.0. So what is a process design kit? A process design kit is a package which consists of file, rules, and documents that help you in designing integrated circuits. So our transistors are metal oxide based, thin film transistor, and we only have N-type TFTs available. Our minimum channel dimension is 600 nanometer currently, our technology node, and minimum width of this transistor is 2 micrometer. You could also build resistors in our technology. As I said, we have a dedicated resistor layer, which is having a high sheet resistance of 200 kilo ohm per square. Also, you could build capacitors, which might be required for analog circuits and some parts of digital circuits. You could build the capacitance of this layer is 2.7 femtofarad per micrometer square. As I already said, you would have 4 metal layers, 2 dedicated metal layers in this 4, and 1 RDL layer to connect to the outside world. In terms of physical thickness, the total thickness of our wafers are around 30 micrometers. And because it's flexible in nature, we have tested so far the minimum bend radius is about 5 millimeters. Our current wafer size is 200 millimeter in our current fabrication FlexLogic 1 line. And as I said, we have very fast turnaround time. You could go from tape out to parts delivery in just about 6 weeks. So to design any circuits or ICs, you will require some components, which is called Pcells or parameterized cells. So I would briefly touch upon what Pcells are available in our PDK and components. As I said, we have our transistors, which is N-type channel only. It's a positive threshold voltage transistor. The transistor is enhancement mode, TFTs. We have resistors, which you can build with dedicated resistor layer. Again, you have capacitors, which are usually MIM-based capacitors. You can form high-value capacitors based using these two layers. I would also want to touch a brief difference between a regular CMOS transistor and pragmatic FlexIC TFTs. So if you look at traditional transistors, you would have all these parasitic capacitors to gate, source, bulk, and drain. Because of our unique offering, that's our substrate is polyimide substrate, there is no capacitance to substrate. So all these capacitance from source to bulk, gate to bulk, and drain to bulk would disappear to zero. Yeah. Next, I would like to touch about the EDA tools and how the flow looks. Our PDK is compatible with industry standard EDA tools. So in the process design kit, what we offer is devices, the basic Pcells that are required for custom level design or analog based design. You could layout them and design them using schematics. For digital design, we would also give technology labs and layer maps. So to use these devices in your circuits, you will need appropriate models. We also provide these models for you. You could use these models to simulate your circuits in the EDA tools. We also provide you with DRC, that's the design rule check, layout versus schematic LVS check, rule decks to appropriately tape out. We also provide you with design rule manuals, which says how to lay out the circuit and what rules you need to follow. There's also a guide attached when you receive the set of PDK documents, which gives you some tips about how to design in our technology and what parameters to keep in mind when designing. We also provide you with an installation guide. The installation of our PDK is pretty simple and straightforward. You just have to follow the installation guide to install this PDKs in your Linux systems. So once you have this PDK, so what you would do next is our PDK is compatible with industry standard EDA tools. That's from Cadence, Siemens, and Synopsys EDA vendors. So once you have the PDK and you have these EDA tools installed in your systems, then what the IC designer would do is start designing. So initially, the IC designer would start with product specification. Then he would go to design a circuit, that is schematic design. Then he would layout this schematic physically, and then they would send us the layouts to do fabrications. Then once you receive these wafers or dies, you would test these and validate your circuits. Also want to touch deeply about what EDA tools and providers we have. This box shows which providers we support. In terms of Cadence, if you want to do custom level design or analog level design, we support Cadence Virtuoso. That's for schematic and layout level design. When you want to simulate your circuits, we have Spectre tools, again from Cadence. You could do your simulations. If you want to do digital designs, we have Xcelium tool, which is required when you design RTL and you do verification. And to go from synthesis to place and route, you would have Genus and Innovus. And to finally close the timings, you could use Tempus and Conformal Leg. In terms of Siemens, we support Calibre, which is used mainly for DRC, LVS, and PEX checks. which are an essential part to tape out. And we also support Siemens digital tools, that is OSS RTL, that's used for synthesis, which converts the design to gate level netlist, and also Upriser, which converts the gate level netlist to layout. We also support K-layout for GDS viewing. And in terms of Synopsys, the tools are still in testing phase. We would try to release the PDK as soon as possible for this. It's still in alpha stage. So now you have the PDK, you have the EDA tools you have designed. So how the FlexIC will be designed, what are the manufacturing specs, and how we would deliver. I would briefly touch upon that. So the minimum die size that you would need to design is 3 × 3 millimeter square. You would have to design your GDS and send us the GDS. The current wafer size is 200 millimeter size in our FlexLogic 1 manufacturing line. Then the reticle shots are repeated over wafer. If you see, this is one of our wafer. If you see, this is a reticle. The reticle shots is repeated over entire wafer, as you see here. Some area is reserved for PCM structures. We do standard parametric PCM testing and reporting. Once we do this testing, we release these wafers externally. Coming soon, as I said previously, in our FlexLogic 2 line, we are moving towards 300 millimeter wafers, which are even more bigger. So once these wafers are manufactured, so how would you receive? Post PCM testing, what we would do is from the glass wafer, we would release the wafer and we would dice them for you, and then place these individual dice in a gel box and deliver this for you. So please note, all these dice are bare dice. Once you receive this gel box with bare dice, you can retrieve them. Using a vacuum pencil, for example. Please handle all these bare dice in an ESD protected area and make sure you are ESD safe at all cases. To test these dice, what we would suggest is you could use wafer probers or probers that's available. You could directly probe on the pads that you have, or you could also attach or integrate this FlexIC using ACP attach method, or use zip connectors on PCBs and insert or connect these FlexICs appropriately. Yeah. Next, I would like to touch briefly about specific application designs and technical publications that use our unique technology. All these achievements are complex. First, I would like to touch about the machine learning algorithm chip that was manufactured in collaboration with ARM. This machine learning chip was a binaural neural network, BNN. This machine learning was used to detect specific odor for odor recognition. This machine learning engine was coupled with a sensor array to develop an e-nose sensor. So the application of this would be, you could use these sensors in packaging environment to check food quality and safeties. So some of the PPA for these, like the area requirements, what power it was consuming is here. Next, I would like to go to 6502 processor, which is a general purpose processor which was used in 1980s or 1990s. This was designed in IMEC and fabricated at our manufacturing line. It consisted close to 2,700 Nano equivalent, and the area was around 25 millimeter square. The speed of this was 70 kilohertz, and it was consuming around 135 milliwatt. This processor was able to process multiple complex computation. It was able to run complex assembly code. And if you have already seen, there was this snake game which was played real time for checking the operation of this circuit. Next, I would like to touch about plastic arm, again designed by ARM and manufactured by us in collaboration. This is an M0 Cortex-based SoC design. It's a 32-bit processor. It has 32-bit CPU, and you can see the main contents are it had processor, it had a memory that's latch-based RAM, and it also had ROM. This design is more generic than the machine learning chip that ARM developed. You could use this for more general or specific purposes. Again, this was one of the biggest circuits. It had 18,000 NAND2 equivalent gates in terms of standard cell. It was consuming around 60 millimeter square in terms of area, and it was working speed of 30 kilohertz. Then I would like to touch about plastic ARM pit. Again, it was designed and manufactured in collaboration with ARM. This specifically is mixed signal design. So it consisted of digital part, which you see here was done in PNR, and also some custom parts or analog parts, which was customly done. The application of this is for recognizing body malorder or recognizing body malorder. Yeah, I would also like to show this. This is some of the important publications we have done in collaboration so far. So if you're more interested to learn more about what can be done in our technology, I would recommend you to go through these papers. I would like to say one thing. If for analog designers or enthusiasts, this is one of the best things. Flexible SAR ADCs was designed using our technology, which you could go through. And all the previous applications that I mentioned are in this publication list, which you can go through. Then for designing some of the digital parts, we required standard cell library. But currently, we do not provide this standard cell library in our PDKs because it is still an alpha stage. So I would like to touch about how we designed the standard cell library, how it looked. So for now, all our standard cell libraries are designed using only N-type TFTs and resistors. Here you could look some example of architecture. This is a resistive load inverter, basic inverter. So the pull down network has an N-type transistor. The pull up is having a resistor, which can be manufactured in our technology. I would also like to touch another architecture, which is pseudo CMOS based style or architecture. Here, the first stage is like a regular resistive based, which is having transistor and resistor. But the second stage would have both N-type TFTs, which would invert the signals. So if you want to design your standard cell libraries, you could follow these architectures and lay out them. We would provide other necessary files like the technology left and layer map once you have these standard cell libraries. For now, it's only N-type transistor. In future, we are planning to have also P-type transistors included in the PDK. So in that scenario, you could design your standard cell libraries and standard cell cells in a CMOS-based style. So I would like to conclude my talk with why you should use our Pragmatic FlexIC Foundry service. We are world leading, low-cost, ultra-thin manufacturer in flexible ICs. It is very, very sustainable compared to silicon, and our delivery time is rapid from tape out to delivery in just a few weeks, as I said. Our PDK is ready to use, compatible with all major EDA tools, and hopefully using our technology, you would enable new applications and bring intelligence to all devices. Yeah. Next, I would like to give to Adil, who will explain more about how to access this Europractice FlexIC MPW service and how to access our PDK. Thank you.
Thank you, Suman. So you have heard about all the applications of FlexIC technology and the technical aspects of the PDK. So the natural question is that how can you access this technology? Of course, the way is to directly go to Pragmatic if you want large scale production or deeper collaboration. But Europractice offers a platform where FlexIC and many other technologies on the spectrum of different kind of application-specific ICs, photonics, and all can be accessed for fabless manufacturing for low volume. Next slide, please. So just a quick overview of what Europractice is. The very origins of Europractice goes back to late 1980s when European Commission wanted to stimulate microelectronics in academia and in industry. And with those concepts in mind, Europractice evolved into a network of more than 600 member institutes by now, spread across all over Europe and North Africa and Middle East. So what exactly Europractice does and how does it facilitate? Next slide. So you see that for a chip manufacturing, basically you need a fabrication facility where chips can be made, usually very expensive establishments, which are usually rare over a geography. Then you need a set of libraries, components, and different design concepts in the form of an IP, an intellectual property, which can be used to create your idea into an actual chip. But then the third thing you need are the set of CAD tools to help you design, simulate, and before you make your design ready for fabrication. So these suppliers and users do have a gap, especially for academia and for spin-offs. It's not always easy or cheap to get access to such tools, IP, or fabrication facilities, and that's where Europractice fits in. Europractice has 5 partners which coordinate and activities for all these 3 aspects of chip manufacturing. Next slide. So Europractice services are based on 3 pillars, which makes it a one-stop solution for all your chip fabrication related requirements. So the first the first pillar is design tools. That's a consortium of all collection of all different CAD providers, which tools are used for chip designing. Then, of course, the fabrication services, where Europractice acts as a bridge between users and fabs all around the world for realizing your chip into an actual device. And of course, a vast portfolio of trainings and webinars where the IP from design tool manufacturers, fabrication houses, and also from the users and design houses are put together and made accessible for its members. Next slide. So this is a portfolio of Europractice design tools. As you can see that pretty much all the big names and also the new spin-offs for different type of IC related technologies. Their CAD designers are present in this portfolio, including Cadence, Siemens, and Synopsys, for which FlexIC PDK provides tools for. So it's through Europractice, it is possible for to receive non-commercial licenses for academia and its spin-offs within Europe, and avail these design tools at a very low price. Next slide. This is a portfolio of different technologies offered by Europractice. You can see that all major fabs for ASICs are present, but then new emerging technologies such as compound semiconductors, can be GaN, indium phosphide, and related technologies, MEMS, photonics, and microfluidics all form this portfolio, and the latest entrant to this portfolio is Pragmatic's FlexIC platform. So basically, these fabs are accessible through Europractice services. Now, why Europractice fabrication services are relevant here? Of course, one can directly have a full mask design and a dedicated run to have their chips fabricated. But Europractice Foundry Services work on the model of MPW, or multi-project wafer. Multi-project wafer model allows to share the mask space between different partners. So designs from different different projects or different customers can be put together on a same reticle size, which can be printed over and over again over so the chip fabrication process remains the same, just the mask space is shared. Some people would, of course, for some projects you need full mask, full reticle space, full size chip, let's say, for your applications. But very often for testing a prototype or testing your initial design or iterating over a new idea, you need a smaller space and quick turnaround time. And that is something what multi-project wafer makes it possible. So mask and fabrication cost is shared between customers, which really reduces the price one has to pay for prototyping their design. You pay as you use, so you don't have to pay for the full mask or for services which you do not need. It's specific to your requirement. And most of the MPW services from Europractice are based on multiple runs per year in a scheduled service. That means that you can very well time development of your device by making it in sync with the MPW runs offered by Europractice. For more information, I invite you to visit europractice-ic.com for foundry service related information. Next slide. So, as I said, Flexible IC is our new addition to the portfolio, and we will be organizing the first MPW run this year. Calendar for 2024 runs will soon be available, and there are multiple runs planned for next year. The first run this year will, if you look at the full timeline of how participation in an MPW run looks like, then of course it starts with an idea which might be brewing for a long time. But is your idea realizable through Flexible IC PDK? For that, you need to get access to the PDK, and to get the access, first you need to sign DKLA, or Design Kit License Agreement. That's an agreement which allows you access to the PDK and more detailed information which helps you in designing your chip. If you're convinced about realizability of your design, then registration is the next step. So downloading the DKLA, getting access to PDK, and registration is all done through Europractice website. The deadline for registration for the first FlexIC MPW run is 15th of November. And then within 2 weeks, you should be able to submit your design, and design submission deadline is 29th of November. After that, once we receive designs from customers, we have it go through DRC iterations or design rule checks, where the designs are checked against the norms which establish their manufacturability, and it's confirmed that designs have no issues in being fabricated. As soon this DRC phase is done in a timed way within 3 weeks in 3 iterations, so that we can all stick to a same timeline. After tape out, fabrication and tape out of the mask, fabrication and subdicing is performed, and the turnaround time is very fast, as Suman mentioned that from tape out to fab out timing can be up to 6 weeks. And then we are expecting that we'll be able to start shipping chips by February of 2024. Next slide. So as I mentioned that EuropracticeIC.com is your main hub for getting all the information about not only FlexIC technology, but all the technology portfolio offered by Europractice. Here you can access the schedule and pricing website, which gives you latest updates about when are the next runs planned and what are the pricing. A quick note about how pricing works in the case of FlexIC service. So the minimum design size is 3 millimeter by 3 millimeter. Larger design size are definitely possible, but we would like to first get to know what sizes you are interested in before you register your design. Manufacturing cost comes to 700 euro per millimeter square. For EuroPractice members, it's discounted to 600 euro per millimeter square. And for your design chip, you receive 50 copies of that chip after the manufacturing. If you're interested in additional copies of that chip, then 500 euro per set of 50 chips is charged, and you can order up to 9 additional sets. That means that from it's possible that you can have up to 500 copies of your chip, which is especially useful for different applications of FlexIC, where you often want to use chips in a disposable way or in a repeated way. As Suman pointed out, that inexpensive, it's a platform which is relatively inexpensive than silicon, and often can be used for testing or using multiple chips at one go. So more information about pricing and your requirement standard, as well as more customized, please feel free to email me at flexicmpw@imacinternational.com. Next slide. I would also like to take this opportunity to tell you that we have an on-site training planned at IMEC. This is a training which will give a bit much deeper dive into the technological aspect as well as the design aspects. So this is a 2-day training to be organized on 4th and 5th of December at IMEC in Leuven, Belgium. This 2-day training involves 1 day of seminars from Pragmatic, but also from the partners and users of FlexIC technology, such as IMEC, KU Leuven, and TU Eindhoven. And the next 1 full day will be dedicated to hands-on training on FlexIC PDK, where you get to see PDK firsthand and see how a design cycle how a design cycle takes place and what are the different aspects of it. So it's a deeper dive into the process design kit of FlexIC. That means that you need to sign design kit license agreement, which is free of cost. You can download it from EuroPractice website, and registration links will open soon on EuroPractice training website. Next slide. And just the last note from webinars such as this and many others are available on EuroPractice YouTube channel. So we are already, you can see there are 8 different series on different technologies with up to 39 technical webinars in the list. We are increasing it more and more. You can learn about different technologies from microfluidics to MEMS, photonics, graphene, and of course, flexible IC. So please visit our YouTube channel. Like, share, and subscribe. Very much welcome for that.